Hello! In this video I want to talk to you about the mean of a distribution. Okay, the mean. And the mean, most of you will know it as an average, but in terms of math speak, it's called the arithmetic average. Okay, the arithmetic average of a variable x or of a distribution. And the only reason why I call it the arithmetic average is to distinguish it from some other types of averages, such as the geometric average or the harmonic average, the geometric mean and the harmonic mean. In this particular case, we're just going to be talking about the arithmetic average, and this is what most people learn the average is. We generally write this as x, the letter x with a bar over it, and this is sometimes called x bar. Okay, and you can also think of it as being the symbol for the sample average or the sample mean. And so this means when you have a sample of data and you calculate an average for that sample, this is the sample mean. And we're going to differentiate that from the population mean, which would be written as mu. Right, this is the population mean, mu. And so if you had data on the entire population of observations, you could calculate mu, which would be the population mean. But when you're just working with a sample, we just use that sample data and we call it x bar. So here we have a little bit different terminology that we'll need to keep straight as we move forward in the course. So how do you calculate the arithmetic average or the mean? Well, to do that, what we're going to do is we're going to calculate the sum from 1 to n, where I equals 1 to n of x sub I. And then we're going to divide that by n. Okay, and just as a reminder here, this symbol, capital sigma, this is the Greek symbol sigma, with the I equals 1 on the bottom to n. All this is saying is that we need to sum, in this case, x sub I, or the value of the variable x for each observation I, across cases 1 to n. Okay, from the first observation to the nth observation. And here, lowercase n is equal to the sample size, as we've used in the past. So this is really just a fancy way of saying you're going to add up all the observations, all the values of your variable x for each observation in your sample, and then we're going to divide by the number of observations in that sample. Okay, so as an example, we could take an array of data. Let's say we had this array, 1, 1, 2, 5, and 7. Okay, and so we've got these 5 observations, and we want to calculate the average for these 5 observations. So the first thing we're going to do is we're going to take the sum of all the values of x. So we're going to add up these 5 observations. And so we would say, okay, the sum from I equals 1 to n, in other words, from the first observation to the nth observation of the xi's, is going to be 1 plus 1 is 2, plus 2 is 4, plus 5 is 9, plus 7 is going to be 16. And then we need to know what our sample size is, or n, lowercase n, and that's just the count of observations here. So 1, 2, 3, 4, 5 observations. And then if we want to calculate the average using this data, using this information that we've gotten so far, we can calculate x bar is equal to the sum of xi, or the sum of the x's across all observations, divided by the sample size, 5. And that would be 3.2. And so we would say in this distribution of data, we could put a little mark here and say here's about where our average is. 3.2 is equal to the sample average. So this would be the average for the distribution. Let's look at another example. Let's say we have another array of data, and we've got 3, 4, 4, 5, 6, and 8. Okay, so we've got these 6 observations here, and we want to calculate the average for these observations. Well, we would start by calculating the sum from I equals 1 to n, so from the first observation to the nth observation. We want to add up all the values of x. And so 3 plus 4 is 7, plus 4 is 11, plus 5 is 16, plus 5 is 22, plus 8 is going to be 30. And we know that our sample size is 1, 2, 3, 4, 5, 6. And so using these data, then we can calculate the average, or the mean, the sample mean, as being equal to the sum of the x's from the first to the nth observation, which is going to be 30, divided by the total sample size, 6, which is 5. And so we know now that our average for this sample of data is going to be 5, right here. And so 5 equals the sample mean. And this is an example of how to calculate the arithmetic average, or the mean, for a sample of data when you have an array.